Alright folks, welcome back to Math Land. Section 3-3, go ahead and check your evens. Pause the video if need be. Elijah's going to take us through a couple questions. What do you got there, sire?
Number 29.
Number 29. You can tell you feel a little melancholic today. D minus 14 equals 5.
Well, my problem was, what?
Is it number 29? This
yeah.
one? D minus 14 equals 5?
My problem was the fact that I had it right, but I didn't have a negative sign on it. Maybe.
So, again, subtraction can be dangerous. If this is any bother to you at all, you can change it into an addition, okay? Subtraction is always adding the opposite. Can you see this okay?
Yeah.
Okay, and now we just do the opposite to both sides. If this is a negative 14, we'll add a positive 14. Okay, so add 14 to both sides, all it needs to happen. I personally would say, okay, D minus 14 equals 5. I'm pretty comfortable with saying, alright, that's subtraction of 14. Now I want to do the addition of 14. Either way, what you do to both sides is the same. Whichever makes the best sense to you. To me, it looks less complicated to say, alright, opposite of subtraction is addition. Okay? But if you prefer to do this, then so be it. This is how I will show all of my work in the future. Okay? D equals 19. Next question, please.
Okay, that's really odd.
It was an odd one. That's true.
No, because my answer is,
Could have been a book error. Next question.
number, I don't know if I have any more questions.
Okay, moving on. Let's do it. Section 3-3. So now we're going to solve these bad boys. Got more equations today. We're going to solve using multiplication or division. Okay, so last time we were dealing with addition and subtraction problems. Today, multiplication and division. We're just going to run through about 6 example problems. Okay, example 1. Solve. Multiply or divide. Okay, what's going to be involved? So, follow along. Here we go. Let's do a negative 5x equals 60. If you got to solve that for x, how do I get x by itself? Okay, you need to recognize, Elijah, that is times. And so the opposite of times, you want to do the opposite to both sides, we'll divide. So divide on this side and divide on this side. Now, divide by what? Well, remember, you're trying to get x by itself. Okay, so if x is going to go away, you got to get the negative 5 out of there. Okay, and so you just divide both sides by that. Okay, do it to both sides. The negative 5 divided by negative 5, you know it's a positive 1, that cancels out. Right? And you're done. Let's cancel out. I mean, that's 1, right? Hey, you should write the 1. 1 times x, 1 times x, 1 times... Yeah, but 1 times x is x, because 1 times anything is itself. Right? Isn't that the multiplicative identity property? 1 times anything is itself, same identical number. So you don't have to write the 1. All right? We finally have x by itself. X equals a negative 12. Okay? So far so good? Let's try a fraction. Y over 12, or I'm sorry, y divided by 12 equals negative 3/4. Okay, what do I do now? Well, we're trying to get y by itself. Right now it's got a division going on. So you ask yourself, well, what's the opposite of division?
Multiplication.
So you're going to multiply, put a little dot for multiply, both sides by that guy. Okay, so if you multiply both sides by 12, times 12, times 12, okay, the 12s, that's now a cross cancellation. If you want to put this over 1, you certainly may, but it doesn't really matter. Y, when you put it all together, y divided by 1, anything divided by 1 is itself, right? So you now have y by itself. Y is equal to. Questions? Does that make sense?
Yeah.
Okay. 4 and 12, 3 times, negative 3 times positive 3, negative 9. Can these answers be checked? Yes. You plug them back into the original. Take the answer, plug it back into the original, see if it gives you a true statement. Okay. Example 3, and we're halfway there. Let's do negative 3 and 3/8 equals 1 and 4/5. Knowing that we don't do a whole lot with calculators here, what do you think would be a good idea?
Turning it into an improper fraction.
Yeah, that's why I don't like mixed numbers. When you do algebra, when you work with algebra, these are a pain in the butt. Okay, so let's convert those. 8 times 3 is 24, plus 3 is 27. So we have 27/8, that was negative, being multiplied to k, equals, what do we got over here, buddy?
Equals 5 9/5.
5 9/5, there you go.
9/5.
All right. So now, here's the thing. A lot of kids tend to make a problem like this hard. They say, okay, this is a number multiplied by k. And Mr. Stroot taught me that when I go to pick something apart and solve for a variable, that I should always do the opposite. And so therefore, the opposite of multiplication is division. So this is something you could do. You could divide both sides by negative 27/8. I'm not going to write it in. Negative 27/8. Maybe you can kind of see my pencil strokes. Negative. So we could divide both sides, right? But then you have division of fractions. And it turns out you can't really divide fractions. But they say that division of fractions, right? If you put that fraction down here, that negative 27/8, right? Division of fractions is simple as pi. You flip the second and you multiply. So really what you'd be doing is you'd be multiplying by the reciprocal of this guy. The reciprocal of this guy. You'd be multiplying by the reciprocal of this guy. So all I'm saying is, why don't you go and work smarter, not harder. Instead of dividing by a fraction, which we know you can't really do, you multiply by the reciprocal. Just multiply by the reciprocal straight away. Straight away. Here we go. I'm going to go ahead and wrap this in parentheses so you don't accidentally think that it's like a subtraction. This is multiplication. I'm going to multiply both sides by the reciprocal of negative 27/8, which is a negative 8/27. Oh wait, should the negative be on the top or the bottom?
The negative should be on the, it doesn't matter.
Doesn't matter. Good answer. Could be the top, could be the bottom, could be sitting in the middle. Either way, negative times a negative is going to give you a positive, right? All right, what you do to one side, you do to the other. So I'm going to do the same thing over here. Negative 8/27. Okay. Now, cross cancel. That stuff's gone. Gone. K is by itself. This is 1 over 1, which is 1. And 1 times k is k. You just got k by itself. K is equal to, now we just got to look for those cancellations. 9 goes into 27 3 times, right? Negative 8 and 5, nothing going on there. So we have positive times a negative, it is going to be a negative. 1 times 8, and finally 5 times 3.
Okay, I have one question.
Question.
When you, aren't you supposed to make a positive when you bring it over here?
What you do to one side, you have to do the same exact thing to the other.
There's a negative sign there.
So the original had a negative, and I kept it a negative. I didn't change that. It's a negative number. Agreed? A negative number times k. So I hung on to my negative number times k. That's what it is. That was the original. Agreed? Mm-hmm. Okay. In order to get rid of it, in order to make this go away, you multiply by its reciprocal. Okay? So flip it. Same number, but the sign doesn't change. The sign is still the same. All we do is flip it. Okay? If it makes any more sense, you can put that negative on the bottom and then bring it to the top, and then top will go to the bottom. It doesn't really matter. But you need another negative here, right? Because a negative times a negative will give you a positive, and I do need a positive. In terms of signs, I don't want to have a negative in front of this k. Agreed with that?
Yeah.
Okay, so I definitely have to multiply by negative. And then finally, the last rule is, remember, what you do to one side of an equation, you have to do the same exact thing to the other side to keep the balance of the equation. Same exact thing. So I multiplied both sides of this equation by negative 8/27. Did we answer your question?
Man, and the addition and subtraction one, you if it's a number that's positive,
Uh-huh.
you have
Addition,
to, you have to
addition and subtraction. We're going to go back to this subtraction problem. Okay? So this is a different deal. All right? So we're doing the opposite operation. Okay? In order to get the subtraction of 14 to go away, we do the addition of 14.
Yeah.
Okay? So the sign changed because negative 14 plus 14 is 0. Right? So I got that to go away. And what you did to one side, you did to the other. So what you're seeing here is, with addition and subtraction, you're doing the opposite sign. Okay? And this has everything to do with the additive identity property, or the addition property of 0, that any number plus its opposite equals 0, right? So you're going to add opposites to get 0. Crucial. But when it comes to multiplication, it's really just the inverse. It's not an issue of signs, right? A over B times B over A gives you that identity. Okay, so when it comes to addition, we're trying to get it down to get a 0 out of there, because anything plus 0, you follow here, buddy?
Yeah.
You're not following me. I'm trying to answer your question, but you're not really with me. So that's boom, that is itself. But when it comes to multiplication, 1 times anything is itself. Now look at the deal here. On this one, yeah, the signs are different. But what about this one? Do you see anything funky going on with signs being opposite? No, there's no opposite signs. They're the same sign. They're either both positive, positive times positive is positive, or they're both negative. Negative times negative is positive. You see? So yeah, there's a slight distinction that you've made. In the previous homework assignment, hey, the sign was different. But in today's homework assignment, boom, right here, we can see the sign is the same. Has to be. I need a negative times a negative to go to positive. That help?
Yep.
All right. 3 down, 3 to go. Try again. Number 4. Negative 5/3 times x is equal to 25 27ths. So a lot like last one. You could divide both sides by negative 5/3. Okay, this is multiplication. The opposite of multiplication is division. But why would you do that? Why would you waste your time? I'm going to go get an eraser. Why would you waste your time doing this, knowing that division of fractions doesn't really exist? Division of fractions, it's simple as pie. Flip the second, multiply. You're going to have to redo it. Right? It's fruitless. It's a waste of time. You're working harder, not smarter. So let's get smart. Let's save ourselves some time. You know, don't you got better things to get on to rather than sit there and take extra time to do your math homework? No. Let's go ahead and do it smarter. So multiply both sides by the reciprocal. So what do we need to multiply both sides by?
The 3/5.
Close. Negative 3/5. Negative 3/5. Okay, I'll just put it in parentheses right there. The reason I did that in parentheses, Elijah, again, is if I didn't, I fear that some poor child might think that we were doing a subtraction problem. And this is not subtraction, it's multiplication. All right? So now this stuff cancels, it's gone. Poof! Isn't that fun? It's gone, all cancels out. Multiplied by reciprocals. X is equal to, do your cancellation, 3 goes on 27 9 times. 5 goes on 25 5 times. All you gotta do is pay attention to your signs. Positive times negative is negative. 5 times 1. 9 times 1. Okay? Again, easy to check if you just plug it back into the original. Questions on that guy? Alright. This type of problem messes kids up all the time because they don't see it. And it's really just because, boy, they don't understand fractions. But kids that do okay with fractions are okay with it. A lot of kids see this like, golly, x is being multiplied by a -4 and it's being divided by 7. I got to do like 2 things on this thing. This one's hard. I got to divide by 4 and then I got to multiply by 7. They're gonna divide.
It's negative.
So they're gonna want to do stuff. They're gonna want to do it in 2 steps. They're gonna divide by 4. All right, divide by 4, and then multiply. They want to do it in 2 steps. Don't do it in 2 steps, man. That's unnecessary, right? Look at this: -4/7 times x. If I told you to multiply that, wouldn't you say, all right, well that's x over what? Wouldn't you say that's -4 times x, -4x? Yeah. And when you say that 7 times 1 is 7, well, that's what that would be, right?
Yeah.
And that's what we got. What do you got here? You don't have a -4 being multiplied and then a 7 being divided. That's not the way I see it at all. I see x simply being multiplied by -4/7. Okay? This is no different than the previous problem. It's just written slightly different. Okay? So yeah, same thing. This is a multiplication by -4/7. Multiply both sides by the reciprocal. 7 over -4. Put in parentheses, make sure 7 over -4. See? -4 cancels, 7's cancel. X is by itself. Work smarter, not harder. It's no different than the previous 2 problems. It's just written differently. It has everything to do with this. If you understand how fractions work, it should make sense. Okay? We're good?
Yeah.
Yeah, good idea. 7 goes to 21 3 times. 4 goes to 32 8 times. Hey, negative times a negative. My answer should be?
A positive.
Positive. I have 8 times 1.
8.
And I have 3 times 1. I'm done.
8/3.
8/3. All right. Okay, we're going to finish it off with an easy one. You ready? And then we're going to call it a day. The easy one, the opposite of x is equal to 15. I want you to solve for x. What?
That's negative.
What's x equal? If the opposite of x equals 15, then what's x equal?
15?
You said 15?
No. Negative 15?
Are you just guessing?
I don't know.
Alright. Alright, check this out. What if I told you to multiply -1 times x? What would that be?
Negative 1x.
-1x? Now, let me ask you this. What's 1 times x? Let me go ahead and split this off. What is 1 times x?
Itself. X.
Yeah, 1 times anything is just itself, right? Alright. So this negative, I just kind of split it up, did a grouping thing here. So I said, alright, pull that off. 1 times x is just x, right?
Mm-hmm.
So -1 times x is simply the opposite of x. Want to try that with a number? Can you believe it? What about -1 times 2? What's -1 times 2?
Negative 1 times 2.
Oh, that's slow.
That's negative.
That's slow. Alright, -1 times 2 is -2. Alright, so look at this. Isn't that the same thing as me just saying, okay, this was 2, and I want the opposite of it. It's just the opposite of. So think of it as kind of the opposite. So the opposite of x, really what you're dealing with here is like a -1. This is a -1 being multiplied to the x. We just don't ever write it. It's the unwritten or the understood 1. Okay? Any number, such as 3,
15.
you can stick a 1 in front of it by multiplication and you haven't changed the number, right? We would never leave an answer like that. We'd say, well, the answer is 1 times 3. Don't you just mean 3? Oh, yeah, of course. But so you can always put a 1 by multiplication in front of anything. So that's all you're dealing with. There's a 1 out in front, a negative 1. That's it, only it's a negative.
That's negative 15.
All right, so therefore,
X equals negative 15.
opposite of multiplication is division. So we'll divide both sides by negative 1, divide by negative 1, and x is equal to, all right, so these cancel, x is by itself. Positive 15 divided by negative 1 is?
Negative 15.
Negative 15. Now when I go to do these problems on my own, do I go through all of that work? Well, I'm going to just say, opposite of k equals negative 2. Do you really think I go through a whole heck of a lot of work? No way, man.
No.
If the opposite of k equals negative 2, then k equals positive 2. Just change the signs on both sides. Okay? If opposite of a equals 7, well, if the opposite of a equals a positive 7, then a equals a negative 7. Just change the signs. Think of it as dividing both sides by negative, or multiplying both sides by a negative 1. All right? So, last problem, tricky? Not really. Not really when you understand what's going on. Okay? Any other questions or concerns there on all that fun stuff? Section 3.3. Pretty easy, right? It's easy? Easy peasy. All right. That's good. Have a look at the homework assignment. 26th assignment of the year. Oh, right on. That's what we want to do today, folks. Page 138. Knock those out. We'll talk about your questions tomorrow. All right? Be good. Stay off the streets. Be a saint, would you? The world needs you. God bless you. Bye-bye.